In this problem, we will construct a histogram. A histogram is a tool we can use to look at a data set. We use a histogram when the number of data values in a data set is relatively large, when using a dot plot or a stem and leaf plot might be impractical. The data that we're going to use to construct our histogram is the following. It came from the 2000 U.S. Census data. And in the data set, we have the median household income for each state in the United States and the District of Columbia for the year 1999. We want to create a histogram to display the data distribution. The very first step in constructing a histogram is to first create a frequency table. A frequency table consists of dividing your data into different classes in which each data value falls into one and only one class, and then counting how many of your data values fall into that class. That's what we call a frequency table. So we need to define and decide what classes we want to use to break up our data values. We see that the minimum median income is a little more than $29,000, and our maximum median income is $55,000. Let's try using classes with $5,000. Here are our classes. The first class is all states that have an income greater than or equal to $25,000 but less than $30,000. The second class is those states that have an income greater than or equal to $30,000 but less than $35,000. Notice how every income value can fall into one and only one class. That is a requirement of your classes. Now we need to just go and from our data set, we need to find the number of states that have income in the range of our first class. So let's do that. How many states have income greater than or equal to $25,000 but less than $30,000? There is only one state, West Virginia. So our frequency for the first class is 1. How many states have incomes between $30,000 but less than $35,000? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 states in the second class. How many states with income between $35,000 and $40,000? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 states. How many states with income between $40,000 and $45,000? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 states. How many states have incomes between $45,000 and $50,000? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 states. How many states have income between $50,000 and $55,000? 1, 2, 3, 4 states. And how many have incomes greater than $55,000 but less than $60,000? 1 state, New Jersey. Now the first step in constructing a histogram is complete. We have a frequency table. We use this frequency table to construct the histogram. Constructing the histogram from the frequency table is a lot like constructing a bar graph. Some of the differences between a bar graph and a histogram, however, are the middle of the category is the middle of each of the classes. So the middle income between the $25,000 and $30,000 is $27,500. So that is where the little hash mark goes at the middle of the class. The other thing is, between our bars in the histogram, there is no space. The bars will touch each other. In a bar graph, the bars are separated based on the category, but in the histogram, they will touch each other. So on the x-axis, we have our median incomes, and on the y-axis, we have our counts. We see that there was one state that had median incomes between 25 and 30,000. So we want to make our rectangular box with a frequency of 1 centered over the middle of 27.5. How many states had median incomes between 30 and 35? 9 did. There were 9 states in the second class. There are 12 states in the third class. Completing our histogram, we had 14 states with median income in the fourth class, 10 states with median income in the fifth class, 4 states with median incomes in the sixth class, and 1 state with median income in the 7th and greatest class. Notice how there are no gaps in between our bars in the histogram. The only time that we would have a gap in a histogram is that if we had a count of 0 in one of our classes. If we had a count of 0, we would have no bar in that category, and that would be the one time that you would have a gap in your histogram. We still need to add a title to our graph and make sure that our axes are properly labeled. So let's do that now. The title of our histogram is Median Incomes for U.S. States. The x-axis is the median income in dollars, and the y-axis is the counts. Our histogram is now complete. Now that the histogram is complete, we need to describe the data distribution by describing the shape, the center, the spread, and whether there are outliers in our data set. How would you describe the shape of this distribution? This distribution is relatively symmetric, so that's the shape. What's the center of the distribution? The center of the distribution would be somewhere around $40,000. What is the spread? The spread is somewhere between 57.5 minus 27.5, or $30,000. And are there outliers? There do not appear to be any outliers from the histogram of our data. What is one disadvantage of the histogram over a dot plot or a stem and leaf plot? Looking at just the histogram, you do not know what the actual data values are. The 9 incomes in the range of 30,000 to 35,000, we don't know what those 9 values are. They all could be 32.5 thousand, they all could be 34,000. We don't know. We only know that there are 9 between 30,000 and 35,000. In a dot plot and stem and leaf plot, we can actually reconstruct the data set. What's the advantage of the histogram over a dot plot or a stem and leaf plot? The histogram can be used on large data sets. It would be very cumbersome to do a dot plot or stem and leaf plot on very large data sets. So that's the advantage of a histogram. Is there only one unique way to define the classes for a histogram? The answer is no. I could have used more classes. I could have used fewer classes. You just have to look at the data in your particular data set and ask yourself what makes sense. If you have too few classes, your histogram will look like a skyscraper. If you have too many classes, all of your data will be spread out and you will have a pancake-shaped histogram. So you have to play with the data a little bit and use what makes sense for the data. In this case, 1, 2, 3, 4, 5, 6, 7 categories was a good number to use for this particular problem.